In Module 14, we are going to talk about the beginning parts of circles, and this first section is going to be about a lot of definitions. The first one is a chord, and a chord is a segment whose endpoints lie on a circle. So in our picture over here, a segment that is on our circle, so the edge is on the circle, so a chord, it would be segment AB, and also segment BD. Our central angle has to be an angle that's less than 180 degrees, and the vertex has to be in the center of the circle. So notice over in our picture that C is the center of our circle, so this would be our central angle, which would be written as angle ACD. An inscribed angle then is an angle whose vertex lies on the edge of the circle. So in our picture, that would be angle ABD. An arc is a continuous portion of a circle, and it's around the edge of your circle, consisting of 2 points or endpoints, and all the points on the circle that lie between them. So an example would be arc AD, or AB, or even ADB. So there's different sizes of arcs, and that's what we're going to talk about next. There is a minor arc and there is a major arc, and if you could probably imagine, the minor arc is going to be smaller than the major arc. A minor arc has to have a measure that is less than 180 degrees. We will use 2 points or 2 letters to name our minor arcs, and it needs to be equal to the central angle. So in our picture over here, DB could be an example of a minor arc, and our central angle DCB, whatever this degree is, that DB would be the exact same measure. For the notation of an arc, instead of drawing a segment line straight across like we did up here for the chords, it's going to be a little curved, kind of a half circle on top of it. A major arc then is a measure of the arc has to be more than 180 degrees. So it's going to be more than the diameter across, so it takes up more than halfway. And we will use 3 points to name it. So if I wanted to go from A to B to D, so that whole arc, I would name that as A, B, D. So I'd follow the letters around my circle, and I use the same arc notation right above my 3 letters. A semicircle then is, think of half of a circle, and since a full circle is 360 degrees, that means that our half circle or semicircle will be 180 degrees. And we would also use 3 points to name it. In my picture over here on the right, I don't have a semicircle because I don't have another coordinate directly across from it, but say I labeled that as point E, then I could say that ADE would be an example of a semicircle if AE is our diameter. Adjacent arcs, you can probably imagine, are going to be arcs that are directly right next to each other. They are going to share exactly 1 point. In my picture over on the side then, that would be arc AD, and I could say that DB would also be adjacent to it since they share the point D, or they intersect at point D. Arc angle postulate means that we can add those adjacent arcs together to form the full arc altogether. So if I add arc AD to arc DB, then that would equal my arc AB. And I would still use 3 letters for AB because I can see that from A to B is less than 180 degrees. And if we put numbers in there, say AD was 80 degrees and DB was 40, then the measure of arc AB would equal 120 degrees because that would add the 80 and 40 together. Now that I've gone through some basics, examples, and definitions, we're going to go through 4 other specific examples. So this time I want you to come up with some examples from this picture over here of a minor arc, a major arc, a semicircle, and adjacent arcs. So notice that there will be multiple answers that you could put. The first thing you want to do, though, is figure out what is this missing angle so that we would know what the corresponding arcs would be that it opens up to. So remember, all 4 of our angles are all around the circle needs to add up to be 360 degrees. So if I add up these 3 angles, we get 260 degrees, so that means the remaining angle would have to be 100 degrees because 360 minus the 260 gives us 100. So now for the minor arc, remember this has to be less than 180 degrees, and our major arc needs to be greater than 180 degrees. A semicircle means that it's equal to 180 degrees, and then your adjacent arcs is right next to it, or they share 1 point. All right, so one example of a minor arc in my picture, I could really use any 4 of those that I could use is QR. So I want you now to give me what is another minor arc that you could use for our picture. All right, so any of the other ones could have been QT or TQ. You could have done ST. You could have also done SR. And you could have actually added some of them together and done TR because that's, well, no, I take that back. That's 180 degrees. So you would need to put together QS. That would be 160 degrees. So that would be a minor arc that you could have used as well up here. For a major arc, then, it needs to be greater than 180 degrees. Not equal to, but greater than 180. So if I add 120 and 80 together, that gives me 200. So I could go from here to here for a major arc. So remember, we need 3 letters when we label that. So either of the endpoints, so Q or S. So if I start with S, I would have to do S, T, Q. So it connected in that same order, so S to T to Q, so that whole arc. All right, a semicircle, we need to add up to 180 degrees, and the only way that we're going to get that is the 120 and 60. So it'd be T, Q, R. Adjacent arcs, we could use many different combinations. So if I wanted QR as one, then I would have to use QT as another. Or if we did ST to begin with, then we could use SR as the second one because those are adjacent. An inscribed angle theorem means that if we have this angle that is on the edge of our circle, and it's not the central angle, then that means that the angle is going to be half of the size of the arc. So I could take half of the arc and that would give me the measure of the angle. But sometimes you're starting with the angle, so if you take 2 times the angle, that will equal the arc. Where we can use that then is if we have a picture with some angle measurements on there. If we have an inscribed angle of a diameter, so notice that this is the diameter of our circle, that takes up 180 degrees right there. And the angle that is across my circle from that arc is my right angle. So if my right angle is 90 degrees, then I know that this arc that is going to open up to is going to be 180 degrees because I can double it. All right, so go ahead and write down some of the things I just added. We know that the inscribed angle is on the edge of our circle, so just an extra little notation there. So this angle right here is the inscribed angle, and we knew that that was 90 degrees because they gave it to us. Next, the intercepted arc is the arc that angle opens up to. So notice I drew these lines on here so I could see this whole arc that the angle opens up to is going to be double the angle. So if you take 2 times our angle measure of 90 degrees, that's going to equal that intercepted arc. And another way we could look at this, we know that this is the diameter of my circle, and we know the diameter will be half of the circle, so that's also how we could get the 180 degrees. But that only works if you have a 90 degrees on the edge and then it's taking up half of your circle. So looking at number 2, this is where we're going to use this intercepted arc and inscribed angle to find the different angle and arc measures. So we need to look at the angle of 40, and we can see that it opens up to this arc CD. Well, if the angle is 40 degrees, that means that my arc is going to be twice that size. So I'd take 40 times 2, and I get 80 degrees for the arc of CD. Now, for the 32, I could do the same thing. So my 32 uses this angle, which means that my arc AB, I could take 32 times 2, and I get 64 degrees for that arc. But we want the value of X. So notice X opens up to this arc right here, and the blue and the purple arcs are the exact same size. So if I know that I have the arc, I can cut it in half to give me my angle. So if I take my 80 and I divide it by 2, that means that my angle X, or the measure of X, is going to be 40 degrees as well. So those 2 angle measures are going to be congruent to each other because they both open up to the same arc across our circle.